Okay, so let's have a look at number 3 now. In 3 part A, given that sine squared theta plus cos squared theta is identical to 1, show that 1 plus tan squared theta equals sec squared theta. Very similar to question number 1. Our starting point is this. We then have to think, okay, how can I get sec squared theta? Well, that is 1 over cos squared. And so how can I get tan squared? That's 1 over, that's sine squared theta over cos squared theta. So that then tells me that I'm going to divide this by cos squared theta, all terms by cos squared theta. So here we get tan squared theta plus 1 equals sec squared theta. And that is exactly what we need to show. So therefore that's done. Part A is done. Nice and easy. Now part B, solving that range, 2 tan squared theta plus sec theta equals 1. Now again, you should remember this is very similar to question 1 part C. I can't change this term here because it's not a squared term. Any squared term from this identity I can change, but I can't change sec theta because it doesn't have a power 2. So that must mean I need to write tan squared in terms of sec. And I can use this identity. If from this identity I make tan squared theta the subject, we get sec squared theta minus 1. So now I can replace this tan squared theta with 2 open brackets sec squared theta minus 1 plus sec theta equals 1. And if I expand this, I get 2s squared minus 2 plus s minus 1 equals 0. And if I write this in a quadratic form, 2s squared plus s minus 3 equals 0. So I've got my quadratic in terms of sec theta, and I can now use the quadratic solver again. So we've got a equals 2, b equals 1, and c equals minus 3. And so the first solution we get is sec theta equals 1. And the second solution we get is sec theta equals minus 3 over 2. Now, we need to solve in that particular range where it includes 0, but it doesn't include 360. Okay. Now, sec theta equals 1 is the same as saying cos theta is also equal to 1. Now, when we get equal to 1, we want to use the diagram. So there are 2 points on the diagram that give us the right solution. One solution is 0. So theta either equals 0 or it equals 360, because cos of 0 is 1 and cos of 360 is 1. But notice that 360 is not included in the range for theta. So this one's not a solution. Now looking at this on the right hand side, if sec theta equals minus 3 over 2, cos theta equals minus 2 over 3. We'll just do the reciprocal of the right hand side. And then I like using the cast diagram. So I'm going to go from 0 to 90, 90 to 180, and back to 360. Now, looking at this, cos theta equals minus 2/3. So that tells me that cos is negative. Which quadrants is cos negative in? In sine and in tan. And what I need to do is get the angle from the horizontal. So if I do theta equals inverse cos of minus 2/3, we get 131.8, which I'm going to store in A in case I need to use it and I don't want to lose accuracy later on. So theta is equal, so that then tells me the angle from the horizontal line on this cast diagram, either this angle is 131.8 or this angle here is 131.8. Now the first one's already been done, from 0 to the first blue angle. To get to the second angle, I'm going to do 360 minus. So then I'm going to do 360 minus alpha A, and we get 228.19, I guess, yeah. But the question, if you read it carefully, says given your answers to 1 decimal place. So you don't want to lose marks on being too accurate. So 131.8 and 228.2. Okay, so that was it's a fairly standard question. Nothing too difficult really about that.